Picture this. You're walking through a forest. It's night, pitch black. You can't see a thing. Then, the trees start bending. Leaves rustle. A branch cracks. Something is close. Something enormous is moving out there. You just can't see it. You can't see it. Can't reach out and touch it. But everything around you is screaming. It's real. Because everything around it reacts. That's the only proof you need. Now zoom out. The forest becomes the universe. The trees, those are galaxies. And that unseen force moving through everything, scientists have a name for it. Dark matter. A substance we think makes up most of the matter in the entire universe. Most of it. We've never seen it, never caught it, never even properly identified it. And yet, its gravity shapes the entire cosmos. So what actually is it? And why have some of the world's greatest minds spent nearly 100 years chasing something they can't even see? The story starts in 1933. A Swiss astronomer named Fritz Zwicky was studying one of the most massive galaxy clusters known to science, the Coma Cluster. He measured their speeds, and what the numbers told him made absolutely no sense. The galaxies were moving so fast that the visible matter couldn't possibly generate enough gravity to keep them together. By every law of physics, that cluster should have scattered across the cosmos. But it didn't. It held together, as if something invisible was adding extra gravitational pull. Zwicky named it dunkle Materie, dark matter. Most of the scientific community brushed it off. It sounded too weird, too out there. But decades passed, and the mystery only grew harder to ignore. Then came the 1970s, and astronomer Vera Rubin started studying something that seemed simple: how galaxies spin. Think of a merry-go-round. Stand near the middle, you barely move. Stand at the edge, you're flying. Scientists expected galaxies to work the same way. Inner stars, fast. Outer stars, slow. Simple. But that's not what Rubin found. The outer stars weren't slowing down. They were moving just as fast. By the rules of gravity, those outer stars should have been hurled out into empty space. They weren't. Something invisible was holding them in orbit. Something with enormous mass, wrapped around every galaxy like a giant halo you can't see. Scientists cataloged everything: stars, planets, gas clouds, black holes, every bit of visible matter they could find. They counted everything visible, and the math just didn't add up. Here's the staggering part. Everything we've ever observed, every star, every planet, is only about 5% of the universe. Dark matter is 27%, and the remaining 68% is something even stranger called dark energy. Every star you've ever looked up at, every galaxy, every person who's ever lived, all of it, a tiny fraction of what actually exists. Fair question. If it's invisible, how do we know it exists at all? The answer is gravity. And gravity always leaves fingerprints. Imagine putting a glass lens in front of a flashlight. The light bends around it. The same thing happens in space. Massive objects, including invisible ones, bend light itself. Scientists call this gravitational lensing. Astronomers keep seeing galaxies whose light arrives warped and distorted, twisted by something we can't see. The gravity is real, far more than visible matter could ever produce, like finding footprints in fresh snow. You never see the creature, but you know something walked through. nearly 100 years of searching, and we still don't know. One leading theory? Dark matter could be made of entirely new particles. Particles so shy, they barely interact with anything. Some physicists point to particles called WIMPs. Others bet on particles called Axions. Different guesses? Same mystery. Massive detectors buried deep underground have been waiting for decades to catch a signal. So far, silence. But here's an uncomfortable thought. What if dark matter isn't a particle at all? A growing number of physicists are asking a genuinely uncomfortable question. What if dark matter doesn't even exist? What if gravity, the most familiar force in the universe, simply behaves differently at cosmic scales? Maybe our whole understanding of gravity is just incomplete. There are alternative theories, but most of them struggle to explain all the observations. One of the biggest ideas in modern science might be absolutely right. Or it could be completely wrong. We genuinely don't know. Today, some of the most powerful instruments humanity has ever built are dedicated to solving this one mystery. CERN's Large Hadron Collider, the James Webb Space Telescope, and vast underground laboratories buried beneath mountains. In 2026, researchers using James Webb data released one of the most detailed dark matter maps ever made. And yet, with all of this technology, the most advanced we've ever built, the mystery remains unsolved. Dark matter might be the invisible skeleton of the universe, the hidden framework that galaxies grow on. Or it might be telling us something even more unsettling, that our understanding of gravity itself is fundamentally incomplete. Something massive enough to shape entire galaxies, powerful enough to influence the fate of the cosmos itself, yet completely invisible to every telescope we've ever built. We found its gravity, but we still don't know what it is. Dark matter isn't hiding from us. It's been here all along, surrounding us, waiting for us to finally understand what we're actually looking at.